Right, so we are revising this quiz. So it has how many questions? It has 10 questions. So we're going to go over all these questions one by one. Okay, we're going to go over these questions one by one. All right, so let's start from question one there. So let's go to my board here. So question one, we have, okay, so on question one, they're saying which of the following has less range of uncertainty between 35 degrees Celsius and 35.0 degrees Celsius. Okay, so which one do you think has a less range of uncertainty between those two numbers? Hello? Which one do you think has the less range of uncertainty? Okay, so for you to answer this question, you first of all have to understand how to find the range of uncertainty. Okay, the other thing that you need to understand is how to tell which one is the uncertain digit and which one is the certain digit when you're given any number. Okay, so I hope you've not forgotten those rules for significant figures. Okay, so the rule is that if you are given a number, say 56, okay, if I'm given this number 56, this last digit here, okay, is the uncertain digit. Uncertain. And then this one here, or whatever numbers will follow, will be on the left side here. They will be the certain digit. Okay. So this certainty only occurs in the significant figures. Okay. So the uncertain digit is the last significant figure in a number. That's the uncertain digit. Okay. So if I wrote a number like this one here, let's say 56102. Okay. So if we follow those rules for counting significant figures, all these numbers here are significant, including this zero, because this zero is what we call as a captive zero, right? So it's between two non-zero numbers. So we have 1, 2, 3, 4, 5 significant figures. So when they ask you which one is uncertain in this case, okay? So the uncertain digit will be the last significant figure. So these two here is uncertain. And then 5, 6, 1, and 0, they are the what? The certain digit. Okay. So the uncertain digit is always the last significant figure in a number. So what if I have 60? I write it like that. Okay. How many significant figures does this number have? So Mampi, you're writing on my screen. Okay, let me cancel annotations.
It
How
has
many
only one,
significant figures? It only has one, right?
one,
Okay.
yes, sir.
So the last significant figure in this number is the uncertain digit. And we see that in this number, we only have one significant figure. So it means this same number here is the one that is uncertain. Okay. So it means for this number, if I write it just like 60, there will be no certain digit in that number because we only have one significant figure. And if you only have one significant figure in a number, that same number you consider it as what? Uncertain. Okay, but what if I write that number as 60 point? Okay, so if there's a point there, it means even this zero is significant, right? Okay, even this 6 is significant. So it means here our uncertain digit will just be what? This zero. It will be uncertain. And then this 6 here will be what? Certain. Okay, so by certain, we mean we are sure that it's that number. But by uncertain, we mean we are not sure if it's that number because we are obtaining these values here using what? Measurement instrument. Okay, so once you identify your uncertain digit, okay, the place where the uncertain digit is going to be, that's where you're going to get what you call as the uncertainty. Okay, so I hope you remember your abacus. So your abacus was like this. Okay, so the abacus was something like this. Okay, let me write it here. So it was something like this. I hope you remember your abacus. Those two are things like that. So we said on the abacus, these are ones. Okay, these are tens, if you can remember, these are hundreds, and then these are thousands, like that. Okay, so if you are given a number, let's say 2005, okay, so it means this 2 here is in the thousands, this 0 here is in the hundreds, this 0 here is in the tens, this one here is in the what? The ones. Okay, so to get the uncertainty for this number, first of all, we are going to identify the uncertain digit. So the uncertain digit here is the last significant number, which is what? 5. So where is 5? Okay, 5 is in the what? The ones. So it means your uncertainty will be plus or minus 1, because the uncertainty digit there is what? I mean, the uncertain digit is in the ones. So it means your uncertainty will just be plus or minus 1. Okay, what if I have 2, 2, and then 0? Okay, and then I want to find the uncertainty for this. So you check this number. Okay, which one is our last significant figure? So our last significant figure here is just this 2. Okay, so this 2 is what? In the tens. Remember, this one, the first one is the ones, this one is the hundreds, like that. Okay, so it means here your uncertainty will be plus or minus what? 10, because the uncertainty digit here, or the uncertain digit, is in the tens. So it means your uncertainty will be plus or minus 10. But here it was in the ones, your uncertainty is just plus or minus 1. What if I have this 200? Okay, so this 200, it only has one significant figure, and that same significant figure will be what? Uncertain. Okay, so it means here these are hundreds, these are tens, these are ones here. Okay, so it means the uncertainty for this one here, since the uncertainty digit is in the hundreds, it means the uncertainty will just be plus minus 100, like that. So that's how we solve these things. Okay, so I hope you've gotten that. Okay, I've explained. So there we've been given now two numbers. Okay, we've been given two numbers. So the two numbers that we've been given here is 35. Okay, we can ignore the units, and then we've also been given 35.0. Okay, so for us to find the uncertainty for this, first of all, we have to identify the uncertain digit. So for this one, the uncertain digit is just this one here. Okay, so this one is in the ones, like that, and then this one is in the tens. So it means the uncertainty here will just be plus or minus what? 1. And then we go to this one. Okay, which one is the uncertain digit? The uncertain digit is the last significant number. So if I write my number as 35.0, it means this 0 is significant. Why? Because there's a decimal point there. Okay, so if there's a decimal point, the trailing 0 becomes significant. So it means this one now is in the what? Okay, so if these are ones, these are tens. Okay, the ones that come immediately after the decimal place are the 1/10. So we can write 1/10 like that. Okay, 1/10. And then the one that can come there will just be 1/100th, and then 1,000th, like that. Okay, so that's what it means. So this one here now, our uncertain digit on this number is in the 1/10s. Okay, or the 1/10th. Okay, so it means our uncertainty there will just be plus or minus 0.1, because here immediately after the point here, that's where I have my uncertainty. That's where I have my certain digit. Hey, that's where I have my uncertain digit. Okay, yes. All right, so it means this is your certainty, and then this is your certainty. So between these two certainties now, I mean uncertainties here, between this one and this one, which one is smaller? Okay, because here we are saying, we are saying which one has less, okay, has less range of uncertainty between this and this one. So you just get the one that has the lower uncertainty. So the one that in the lowest uncertainty is 35.0 degrees Celsius. So your answer here is just going to be B. Okay, so I've explained everything that you need to know in order to find the uncertainty, to identify the uncertain digit. Okay, so any questions there on question 1?
Sir, I have a question.
Yes.
The 35.000, the one on the right.
This one here.
We fix the 1/10,
Mm-hmm.
and suppose
Okay.
suppose the
Mm-hmm.
answer, the uncertainty one was if at all the uncertainty one was supposed to be the 1/100, how are
Mm-hmm.
we going to write it
Okay,
in
so
terms of plus?
okay, in terms of the uncertainty, if this one was the uncertain digit, okay, so it means your uncertainty there will be plus or minus 0.01. It will be like this. Have you seen the pattern?
Yes, sir.
Yes. So if the uncertain digit was this one, it means the uncertainty there will be plus or minus 0.001. Okay.
Yes, sir.
All right. So let's go to question 2 now. Okay, let's go to question 2. So question 2, it's on the number of molecules given moles. Okay, so they are saying how many molecules of nitrogen oxide, nitrogen dioxide, I mean, are contained in 0.71 moles of nitrogen dioxide there. Okay, so here we said we can use the atomic mass approach, or if you want, you can use the Avogadro's constant approach. Okay, so the Avogadro's constant approach is the simplest. You just say one more, okay, of anything contains 6.022 times 10 to the power 23 particles. So this is what we are going to be using if you have such a question. Okay, so meaning what? Meaning that these particles here, they can be molecules, okay? They can be atoms, they can be ions. They can also be electrons, okay? So in this case here, they're saying how many molecules of this are contained in these moles of uh, NO2. Okay, so what are we going to do there? We're going to say one mole has 6.022 times 10 to the power 23 molecules, okay, of this NO2. What if I have 0.717 moles? How many molecules am I going to find there? So we're just going to cross multiply. So cross multiply x multiplied by this, you're going to get x is equals to, and then this number here multiplied by this, what are you going to get? Okay, so let me multiply on my calculator. So 0.717 times 6.022, okay, I'm finding 4.31777 and then times this 10 to the power 23. Okay, so these are molecules. So you can just round this off to best suit the answer that is there. So if we round this off, we're going to get, okay, we're going to get 4.32 times 10 to the power 23 molecules. Okay, so that's it on question 2. Unless you have questions.
Yes, I have a question. I've understood, but
Mm-hmm.
I want to know which one
Yes.
is the correct formula for the Avogadro syndrome. Because in other tutorials which I went through
Mm-hmm.
on on that page, it's written in other questions you are writing 6.023.
Yeah, so it's just a slight difference. So you can use
So it's either use it over
0.0.
two.
Yes, even if we used 6.023 like that, right? And then
Okay.
times 10 to the power 23. So it won't make a difference. If you use this or this, the answer will still be the same.
All right, sir. Thank you,
Yes.
sir.
All right. So now let's look at question 3. So question 3, they're saying how many, okay, how many total atoms are in 4.50 times 10 to the power 18 molecules of sulfur dioxide? Okay. So when we have a molecule like sulfur dioxide, like this is one molecule of sulfur dioxide. So how many atoms does it have? So you count all the individual atoms there. So I have one sulfur plus two oxygen. So it means the number of atoms here in just one molecule of this sulfur will just be what? 3 atoms. Okay, we have one sulfur atom and then two oxygen atoms. Okay, so that's the ratio that we are going to be to use here. We are going to say in one molecule, okay, one molecule of sulfur dioxide, there are 3 atoms. Okay, and then from there now we can use we can substitute with what we have. So here now I have 4.50 times 10 to the power 18 molecules of this sulfur dioxide. How many atoms am I going to have? So cross multiply. Okay, so cross multiply, it will be x multiplied by 1. So x is equals to, and then this here multiplied by 3. What are we going to get? So let me try to multiply. So I have 4.5 multiplied by 3 and then multiplied by 10 to the power 18. So if I multiply this 4.5 and this 3, I'm getting 13.5 and then multiplied by 10 to the power 18. Okay, so now these will be atoms now. Okay, and then the last thing that you should do is make this number to be in scientific notation. Okay, so the way it is here, this is not scientific notation, guys. Why? Because this number here is greater than 10. So in scientific notation, this number here should always be 1 greater than 1, and then it should be less than 10. Okay, so this 13 is greater than 10. So we need to make that number to be less than less than 10. So what are we going to do? We're going to move this point one step to the left. So it will be 1.35 times 10. Okay, here I had 18, but since I've moved this point one step to the left, it means I'm going to add 1 to this 18. So that will be the power 19 and then atoms. Okay, so you look for an answer that has this. So when you come here, you're just going to find it on C there. So you pick C as your best answer there. All right. And then let's go to the next question. So the next question, okay, so pay attention here. They like bringing this question, and I'm very sure it's going to be there, okay? So I'm going to give you scenarios of different questions that they can ask you just on this same question here. So pay attention, please. So they're saying the moles of hydrated iron sulfate. Okay, so this is the hydrated iron sulfate. So hydrated iron sulfate, it means to this iron sulfate, they are just adding what? Water. That's what it means to be hydrated. Okay, so the moles of hydrated iron sulfate sample were determined as 1.0 moles. Okay, and then now the question comes. They're saying determine the moles of hydrogen molecules in this hydrate. Okay, so what you do is first of all write this formula that you've been given. 4, then point. Okay, so here we've been asked determine if I have one more of this whole thing here. Okay, if I have one more of this whole thing, determine the moles of hydrogen molecules. Okay, so how do you represent a hydrogen molecule? A hydrogen molecule is just what? H2, like that. This is a hydrogen molecule. When two hydrogens are bonded together like that, that's a molecule, okay? So in this one mole, okay, of the hydrated iron sulfate, how many moles of hydrogen molecules can we see? Anyone to try? How many moles of hydrogen molecules can we see?
7.
Exactly, okay, so there are 7. So there's a 7 and then there's H2. Yeah, H2. So this one here is just one molecule and then we are multiplying by 7. So it means there are 7 molecules, okay, of the hydrogen. Okay, so there are 7 molecules of the what? The hydrogen. So you pick your answer as 7. So that's one of the questions that they can ask you. Okay. So now what if they ask you this question? Okay. They say here, determine the moles of hydrogen, and then they put atoms instead of molecules. Okay. So an hydrogen atom is represented as just H. Okay. Just represented as just H. So in this 1 mole of this sulfur, okay, hydrated iron sulfate like this, how many atoms of hydrogen can you see?
14.
14, exactly. So you just multiply 7 multiplied by these 2. You are going to get 14 atoms. So that's one of the questions that can come, this one here. Okay. And then they can also ask you about water and also about what? Oxygen. So for the oxygen, they're just going to ask you how many moles of oxygen, okay, atoms can you see in 1 mole of this chip, whole thing like that. Okay, so the moles of oxygen here, you just get this 7 is also going to the oxygen. So it means the moles of the oxygen atoms there will just be what? 7. And then they can also ask you the moles of water. Okay, so the moles of water, all this thing here is water. So we have 7 of the water. Okay, so in 1 mole of this, we have 7 moles of water. Yes, someone has their hand raised. You can ask.
Yes, sir, I have a question. You've
Mhm.
said why have we put 7 as the number of moles of oxygen? What about the other oxygen, the one which is on the ferrous sulfate?
Oh, yeah, yeah, yeah. Okay, good observation. So I didn't notice the other oxygen there. Okay, so we have 7 moles of oxygen from this water here. From this water here, we have 7 moles of oxygen atoms. Okay, and then from this formula here, we have what? 4. So the total moles of oxygen here will be actually 11. Okay, so thank you for that. Will be 11. So you also add the ones on the iron sulfate. Okay, so they can also ask you oxygen atoms. So make sure you also consider this one. Yeah, so if you have a question, just ask.
Sir, on the oxygen,
Mm-hmm.
uh, and since we're counting the number of moles, isn't it supposed to be 7 plus 1?
7 plus 1.
Yes, since there's only on the ferrous sulfate, there's only one molecule of oxygen and then 4 atoms of oxygen.
No, you are counting the atoms. Okay, so if the question is saying oxygen atoms, it means you have to count all the individual atoms in that molecule. So here, this
Okay.
indicates that we have 4. We have 4 atoms of oxygen there. And then there we have 7 and this oxygen. So here we have 7, there we have 4. So we add.
Okay, this is the number of atoms.
Yes, because we are talking about the atoms there. So you count them.
All right, thank you, sir.
Okay. All right, and then for the water, we just get 7 there. So those are the potential questions that can come, okay? But they may not bring this formula. They can bring another formula, but how you do it is just the same, okay? How you do it is just the same. All right, so what if here they bring maybe not 1 more here. They bring maybe another number, let's say 3 more. Okay, so if they bring 3 moles, then you have to use a mole ratio. Okay, you are going to say in 1 mole, okay, of this whole thing here. Okay, if we are looking at molecules of oxygen, so in 1 mole of this whole thing here, I have 7 molecules. I mean 7 moles of hydrogen molecules. Okay, 7 moles of hydrogen molecules. What about if I have 3 moles of this whole thing here? How many moles of hydrogen molecules am I going to have? Okay, so take note the number that you've been given there as well. There we have been given 1, no wonder we're just going direct. But if it's another number, it means first of all have to make this assumption and then now find the exact moles that will be in that number. Okay, let's look at question 5. So question 5, they're saying um, a 3.400 milligram sample of X contained 7.380 times 10 to the power minus 5 moles of X. So this is the mass, this is the mole. And then the question now is determine the molar mass of X. Okay, so we know that moles are just equals to mass over molar mass. So here we have the mass and we have the moles. It means we can find this molar mass. So we make it the subject of a formula. It's going to be molar mass is equals to mass over what? Moles. But make sure that your mass here is in grams. Okay, and then these moles are always in moles. Right, so it means we have to change this milligrams here. We have to change it to what? To grams. So what do? We just multiply by the prefix, by the value of this prefix, milli, okay? So from your metric table, I hope you haven't forgotten how to convert units. From your metric system or your metric table, we said milli, okay? Milli means 10 to the power 3, like that. Hey, 10 to the power minus 3, I mean. 10 to the power minus 3. That is milli. Okay. So where there's just m there, we're just replacing with this. So we are going to say 3.400. And then where there was m, we are going to say times 10 to the power minus 3 and then grams. Okay. So we've converted from the milligrams to the grams. So now we also have the moles. So to find the molar mass, we can just divide those two. So let's find the molar mass now. Okay, so the molar mass will be, molar mass is equals to the mass 3.400 times 10 to the power minus 3 divided by the moles, which is 7.380 times 10 to the power minus 5. So here, if you don't want to get confused, okay, you can type all this in your calculator quite all right. But if you don't want to get confused, separate them. Okay, so this here, we are going to deal them together, and then even these here, we're going to deal with that part alone. Okay, so here you first type on your calculator 3.4 divided by 7.38, like that. So if I divide that, what I'm getting is this. I'm getting 0.460704670, and then multiplied by, and then here I have 10 to the power minus 3, here 10 to the power minus 5. So this 10 and this 10 are the same base. So what are we going to do? We are going to subtract the powers. So it will be 10 minus 3 and then minus 5, like that. So that will be 10 minus 3 plus 5, which will just be 10 to the power 2. So here I'll write 10 to the power 2. And then 10 to the power 2 is the same as 100. So I'm multiplying this number here by 10 to the power 2, which is the same as 100. I'm going to get 46.0704607 grams per mole. Okay, so you can just round it off to the required decimal places here. So we round it off to 2, it will be 46.07 grams per mole. And then you go on your answers, you check. So we can see that it is there. It is here. Okay, so you choose C as your answer. Unless there are questions. Okay, I think this is straightforward. So let's look at question 6. So question 6, okay, you have a question?
Sir, our answer was 46.07. What about that rule which says the number before the decimal is supposed to be greater than 1 but less than 10?
Oh, that one is when you are putting you are putting your answer in scientific notation. This is not scientific notation, it's just a number.
All right, sir.
Okay, so let's look at question 6. Okay, so question 6, I already explained what to do here on question 1. So they're saying the concentration of calcium in a milk sample was recorded as 380 parts per million. Okay, indicate the uncertain digit in the measurement. Okay, so which one is the uncertain digit in the measurement there, according to what I explained?
8. 8.
Okay, very good. Okay, so we are going to pick 8 here because it is the last significant figure in that number. Okay, so we just put B there as
Yeah.
our answer. And then the following question is also from that same question. They're saying the constitutional, okay, was recorded as this. What is the range of the uncertainty? Okay, so 8,
Mm,
0, I mean 8, 380. So the uncertain digit is this one. And we see that this one is in the what? The
mm,
tens. It's in the tens. So it means the uncertainty is plus or minus what? 10. So to find the range, we're going to get this same number that we have, and then we're going to find the upper reading and the lower reading. And then to find the range there, okay, we are going to subtract
mm,
the upper reading minus the lower reading. So for us to get the upper reading, okay, so upper reading, we are going to say the number that we've been given plus the 10. So it means the upper reading there will just be what? 390. And then to get the lower reading, we are going to say 380 minus 10. So this is going to give us 370 like that. Okay. So now to find the range, we are going to subtract the upper reading 390 minus the lower reading 370. So this is going to give us what?
mm.
20. So you go there and pick your 20 as your answer. Okay, so be careful with the Tuma numbers that they put here. Sometimes they will put a number like this with a decimal point there. So if you are in a hurry and you don't see this decimal place, it means all your answer is going to be wrong. Okay, if there's a decimal place there, it means
Mm-hmm.
even this zero is significant. So it's going to be the what? The
Significant.
uncertain. It's going to be the uncertain digit.
Mm. Yes.
Okay, that's how you solve
Mm.
that one. Okay, let's look at the last three
Okay.
questions here. Okay, so these are on atoms and their subatomic particles, electrons, whatever, whatever. Okay, so what you need to know is that a neutral atom, meaning an atom without any charge, contains an equal number of protons and electrons. Okay, so all those elements that you can see on the periodic table, they are neutral. So it means the number of protons and the number of electrons, they are what? The same. Okay, they are the same. And the number of protons,
That's the
okay,
number of what, sir?
the number of protons and the number of electrons, they are the same in a neutral atom. That's what I was saying.
Protons and electrons.
Okay. And then the number
Okay.
of
Mm.
protons, okay, give the identity of that element. Okay. So an element has a fixed proton number, okay, or the number of protons. And from the proton number, we can tell its name or its identity. And then the number of electrons, okay, gives us the chemical interactions that atom can participate in, okay. And depending on the number of electrons that you are going to have negative charges or positive charges. So if you gain electrons, it means you have increased the negative charge. So it's going to have a negative ion. And then if you lose electrons, okay, it means you have reduced the electrons and the protons are more. So you're going to have a positive what? Charge. So it's very important to know that the electrons, they can move. Okay, they can be lost, they can be gained, but these protons are always constant. They are going nowhere. They're just there in the nucleus. Okay, they're going nowhere. And then we also have a third subatomic particle, which we call as the neutron. So the neutron is responsible for what we call as the isotope. Okay, so depending on the number of the neutrons that you have in that atom, okay, it will affect, I mean, it will tell us what isotope it is. Okay, so now let's look at this question here. We want to fill in this table, so we want to fill in here, here, and there. Okay, so they're saying the number of protons in the nucleus is 35. The number of neutrons in the nucleus is 44. And then the number of electrons is what? 36. So we can see that the number of protons and number of electrons are not the same. So if we have a higher number of electrons than the protons, it means this guy here has to have a negative charge. Okay, so on the net charge here, you're just going to write negative. Okay, because 36, which is negative, and then plus 35, which is positive, is going to give you -1. Okay, what about the atomic
Mm-hmm.
number? The atomic number is the same as the number of protons, so you're just going to write 35. Okay, and then here they're saying the mass number. The mass number, okay, mass number is the sum of the protons plus the neutrons. So this is going to give you protons, we have 35 plus the neutrons 44. So it means we're going to have 79 as the mass number. So here you just put 79. Okay. So it's very important to note that the neutrons here, they affect the mass of the atom. Okay, if they change, they affect the mass of the atom, okay, to form what we call as isotopes. And then the protons, they just remain constant and they give us the identity of the element. So depending on the number of protons that you have there, you can tell, okay, that this element is such and that. Okay, so you just go to the periodic table and then look for the element that has 35 as the proton number. Then you'll be able to come up with the name here. But here it was not required. So if you go now to your questions, they're saying indicate the mass number. We found it was 79. Then indicate the atomic number. The atomic number is the same as the proton number, which is just what? 35. Then what is the net charge? The net charge is the minus. All right, so any questions there? We are done with this
So
quiz.
So wait, so I have a question.
Yes, you can ask.
Wait, what did you say on the on that 70 on that mass number on the 79? Where did you get the 79 from?
Okay, so the 79, we get it when we add
Mm-hmm.
the number of protons and the number of neutrons. That's where we get the 79. So here the number of protons we have 35. Then the number of
Mm-hmm.
neutrons we have what? 44. So you
Oh,
add.
protons and neutrons. Oh.
You've seen it?
Mm-hmm. Yes, sir.
All right, so we are done. You
Protons
can
and
find more videos for quiz revisions on the website. Okay, you can find more videos on quiz revisions on the website. They are both written solutions there, and they are both there's also video there. Okay, so you can try to go through that before your quiz tomorrow. Okay, so do I have any other questions? Okay, so if there are no questions, thank you so much and all the best as you write your quiz tomorrow.
Thank you.